So, good day, Ma'am Julie, and to my fellow Athenians. I am John Ronald Benetrente, and our topic for today would be exploring 3D printing innovations. And this PowerPoint is made by Leo Fancha and Hazel Salvador. So now let's begin. So, the history of 3D printing has its own timeline, and 3D printing emerges in 1984 with average price of a machine costing around 300,000 US dollars. And on 1989, Stratasys was founded and FDM was patented to Stratasys. Now, in 1999, FDM first used in manufacturing with OREC, and engineered organs bring new advances to medicine. And on 2000, 3D printed model helps surgeons plan separation of conjoined twins. First working animal kidney was also created in that year. Now ahead to the year 2005, RepRap project founded by Adrian Bowyer, the University of Bath, and in 2007, Object introduces multimedia printing. In 2009, MakerBot starts selling 3D printing kits, and Stratasys' first high-performance FDM thermoplastic comes to the market. On 2014, Stratasys introduced first color and multi-material 3D printer. And on 2015, Desktop Metal is founded. And in 2017, Tritech 3D joined the Stanford Marsh Group. And also, Tritech 3D becomes DM partners. So now, for our introduction, what is 3D printing? 3D printing revolutionized manufacturing by transforming digital models into tangible objects through layering materials. So, meaning digital models can be made into something that we can touch, into something that is a solid object. So, meaning something that you made digitally will be made possible to be held by you through 3D printing. Similar to traditional printing, it constructs objects layer by layer, enabling the creation of complex 3D shapes. So this process was invented by Chuck Hall in 1984 with his invention called the stereolithography apparatus, or also known as the SLA. And his idea was to help companies develop products faster by making prototypes quickly. So here in the picture, you can see the process, and it involves solidified and liquid resins. And there's also a scanner system and a laser. So that's one of the processes of 3D printing. So now, here are more various processes that are present in 3D printing, which starts in number one at powder bed fusion, in which this process uses thermal energy from an electron beam, or also known as a laser, to selectively fuse regions of a powder bed together, layer by layer, until a part is formed. Its second process is a VAT photopolymerization, which includes DLP and SLA. This process creates components layer by layer using a light source to cure liquid resin. DLP projects complete layer images onto the liquid, while SLA uses a UV source or laser. On the third process, it's called the binder jetting, in which this process works by depositing a fine layer of powdered material, such as polymer sand, ceramic, or metal, onto the build platform of the 3D printing. And for the fourth process, which is the material jetting, it uses one or more print heads to deposit layers of liquid material. Each layer is cured before the next layer is produced, as seen in the picture. So in the fifth process, this is the so-called FDM that was been mentioned earlier, and it's the fused deposition modeling, in which this process is a heated nozzle melts a filament spool, which is then placed onto a build platform in predetermined areas to cool, which forms a layer. And the build platform descends for the next layer, which leads us to the sixth process, which is the sheet lamination, in which this process includes ultrasonic additive manufacturing, or also known as a UAM, and a laminated object manufacturing, which is also known as an LOM. So UAM uses ultrasonic welding to join thin metal sheets with low energy and temperature requirements. And lastly, the seventh process is the direct energy deposition, in which this process uses a layer, electric arc, electron beam, or another form of focused thermal energy to fuse powder or wire feedstock as it is placed. The process takes place horizontally to create layers, which are then stacked vertically for part creation. So, what are the benefits of 3D printing? How is it helpful to our environment? Is it really harmful, or is it a process that contains good benefits? So, for our research, it says that the benefit of 3D printing includes environmental efficiency, in which 3D printing uses around 90% of standard substances and produces less waste, resulting in a diminished carbon footprint during production and the working life of products. Its second benefit includes industry applications, meaning 3D printing can be something valuable for architects in mock-up creation, mechanics for tool production, and media houses for customized promotional gadgets. Meaning this could be helpful for people that are gonna work in the industry, such as the architects. It could help them improve, or it could help them have a better vision or perspective of their own projects. Also, the benefit of 3D printing is it's also an efficient design, which allows for lighter and more powerful product designs, contributing to sustainability efforts. Also, 3D printing can be a cost-effective solution because 3D printing enables cheap prosthetics, spare components, quick prototyping, and personalized items. So that's all for our um, presentation, and these are our references in making this PowerPoint. And we hope you learned something today. Please stay safe and take care always. Bye.